Great.
Cool. Good to go. So that was just a quick introduction to the Easier Data initiative, and that's in collaboration with the Filecoin Foundation for the Decentralized Web. And we wanted to start up this working group. We started with, what was it? It was the Web3 plus Geospatial working group. And then based on some feedback from the community, we've kind of revised that now to the Decentralized Geospatial Web working group. And so that's kind of what we've been calling it. And we're really still defining, what that is and what that can be. I think there's a lot of things at that nexus that we can be interested in, from DApps to geospatial data, to kind of opening up data access to compute over data for science and geospatial science. And so I'm really interested to see what other folks are interested in and where we can take that. And we thought a great way to kind of kick that off was to have John with us here as a guest speaker to talk about some of his experiences with Astral, Toucan, the ecosystem at large. So before I kind of hand it over to him, I wanted to also have the opportunity for other folks to introduce themselves. Nothing kind of, just quickly, if someone wanted to introduce themselves and say what their interests are, you don't have to, but we have time if anyone wants to introduce a project or a particular interest. So I see already that we have one. So if you wanted to kick that off, feel free.
Oh, thanks. My name is Mo. My pronouns are they, them, and I am a decentralized software consultant. So I've been working a bunch in kind of peer-to-peer and with some of these like open metaverse groups working on standards for how to actually load objects over decentralized networks. So I'm mostly here because I've been working on peer-to-peer databases and thinking how we can have collaboratively created decentralized spatial indexes, and how we can make those fast so that we don't need large centralized databases to load spatial data. So very curious to see what people are thinking about on the data layer and seeing if there's points of collaboration we can have.
Awesome. Thank you so much.
I would say you're very much in the right place and very welcome.
Yeah, I've been meaning to come to one of the spatial working group meetings, but it's just like the calendar never aligned. So this meeting is a lot more opportune.
Any other folks want to do a quick intro?
I'm not sure how to raise my hand on the Zoom sidebar, but I can go.
Yeah, I think we're a small enough group that folks can go ahead.
Hey, everyone. Well, happy to be here and good to see you again, John, at least virtually. My name's Ryan. I'm working on a project called Foam. Currently, our main focus is about on-chain location proofs that can be utilized by smart contracts. The way we're working on that is with terrestrial radio-based systems that can be deployed in groups of 4 or more, what we call zones. An area like a university might be a great area to test that. But we've been working in the blockchain geospatial space for a number of years, and in the past have kind of explored on-chain encoding standards and ways to make like front-end visualizations with dGWWG and Mapbox that work with indexes of blockchain data. So really happy to see this group come together and be a part of it.
Awesome, thanks. Hidenori?
Thank you. Good afternoon and good morning, everyone. This is Hidenori. I'm working for the Geospatial Information Authority of Japan, which is a national mapping agency of Japan. And I'm also chair of the domain working group on smart maps under the UN OpenGIS initiative. This initiative is some group of voluntary contributors to contribute to the UN peacekeeping operations. And we are trying to use the IPFS interplanetary file system to host the data, various data, including the COG data, but also the vector data, including the vector tile data, because I'm from mapping agency. So I'm so excited to join this group, and I would like to learn a lot about the domain, so about the decentralized Geospatial Web. Thank you so much.
Perfect, thanks. Carson?
Yeah, hi, my name is Carson Farmer. I represent the textile team who helped sort of kick off the initial Easier initiative and then stepped out of the way when people with real amounts of money got involved. But I'm just here as a former geospatial professional and academic, and now a database, peer-to-peer database person. We don't have a special name for it yet, maybe. Mauve and I could come up with something maybe. But yeah, I'm here as someone who's long been in the geospatial world and has moved into sort of peer-to-peer databases, and is now very keen to see those two worlds come colliding and solving real world problems.
Perfect, thanks. I think next up is Volker.
Hi, I'm Volker. So my background is I've been in the open source geospatial world for the past, I don't know, 15 years or so. So more obviously in regards to the OSGeo and stuff like this, and post4G conferences and so on. And then I worked on databases. And so when I got involved into IPFS and so on, one thing I really want to see, and so I gave myself a 10 years time frame, and now I'm already 5 years in and haven't made much progress, is I want that the European Space Agency distributes their data internally over a peer-to-peer network. Like, it of course doesn't need to be IPFS, but could be IPFS, but just how the data distribution currently works is just so error prone and so wasteful and so on. So this is what I try to get into, and hopefully I still have 5 years left to get this working. All right, that's all.
Perfect, thanks. Caitlin?
Hi, everyone. It's good to see so many familiar faces. My name is Caitlin. I'm with the Filecoin Green team at Protocol Labs. I'm here to learn from all of you. I also have our awesome developer on here, Moza. We're here to learn about what you guys are working on, different uses of geospatial data in the decentralized web, and to see how we can support and improve something that we're working on, which is called CO2.storage. So happy to chat with all of you and learn from you all.
Perfect, thanks. So I didn't see, oh, one more hand. Yeah, David.
Hey guys, my name's David. I'm here from dClimate. Thanks for the invite, John. We've been working in the geospatial space for quite some time now. I would say at this point, 2 years, building on IPFS and other distributed systems in order to make geospatial data more available. And I can drop some links also in the chat, but I'm super excited to be here and see what everyone else has been working on and how we can work together to make data more accessible and usable in the ecosystem.
Awesome, thanks. And Christian?
Hi, everyone. I'm Christian. I lead the data for Arbol. It's a climate risk management company that uses IPFS and dClimate as our core infrastructure. So Dave and I work very closely, and I'm very interested in peer-to-peer technologies, IPFS, and how we can expand the data ecosystem of the world.
Awesome, thanks. I don't see any new hands. So
hi, yes. Hi, my name is Sankara. I'm a technical product manager with Filecoin Foundation. And my interest is to see how I can support us as we continue to onboard data on the network. So if you have any questions about data onboarding tools, protocols, feel free. Thanks.
Perfect, thanks. I'm going to put a HackMD link in the chat one more time. And then I think if there's no other intros, I'll pass it over to John and let him take it away with his brief presentation, and we can just kick it off into an open discussion after that.
Cool. It's so exciting to see everyone. And I'm beyond grateful for the opportunity to speak and feel quite a lot of responsibility because this is the first meeting. And anyway, yeah, I'm really, really excited to be here. I see a lot of familiar faces in the crowd, but I also see a lot of new ones, which is, it's not that I'm not happy to see you, David, but like to see the new people here who have been working on this and kind of pushing these ideas forward is really, really, really exciting to me. So my name's John. I am one of the co-founders of Astral protocol, along with Holly Grimm, who's here. And I'm also one of the co-founders of Toucan protocol, which is building digital tools to unlock climate action at scale. I kind of look at Astral as my main side project. It's something I've been working on for several years now as a labor of love. And so my day-to-day is focused on scaling carbon markets using blockchains at Toucan. And I'm here to talk about Astral and hopefully to kind of seed some ideas, share some work that we've done, and maybe put a bit of shape to what we could do with this working group. I do have a very, very lightweight little presentation. I've got probably about 10 minutes just to go over what we're doing at Astral and kind of the vision. And then really I'm excited to listen to what other people are thinking about, talking about, building. So let me share my screen and then we can, that time when you need to find your, here we go. Cool. Okay. Can everyone see this Figma that I've got?
Yep.
Looks good. Cool. Okay. So at its heart, Astral is really an open source research group. We've been working on these ideas of how do we build with spatial and location data on the decentralized web for about 5 or 6 years now. I'll kind of sketch out the overarching vision, but really a lot of this came through work that I was doing during my master's course at University College London. I studied a course called Spatial Data Science and Visualization, and at the same time was going really deep on Web3, smart contracts, consensus networks, and just naturally found myself asking, what happens if you try to fit these two together? Turns out, as you all probably know better than me, it's really, really technically challenging, but we also have been seeing that there are some very, very interesting use cases that emerge if we can figure out how to build with spatial and location data on the decentralized web. So I'm going to sketch a bit of the work we've been doing at Astral out. This is very much a work in progress. I kind of emphasize that this is an open source research group because really I'm looking at this community as the Astral community, and any work that you're doing, we would like to figure out a way to support, whether that's by connecting you with people in our network, whether that's helping support with ideas. And we've got quite a lot of technical work we've done in the past that might be relevant to your work. We also have, we're purely public goods funded, mainly through Gitcoin grants, although also through some grants we've received from Filecoin Foundation, dClimate, and others. But that's also something that I'm keen to talk about, is how we can use some of the funding we have available to accelerate the development of this. All of this is rooted in the principles that sit behind Web3, right? So we really want to lean into this open source ethos of building for the composable web and managing this shared resource, which is the record of Earth's history, right? So I'll kind of walk through a couple of the kind of top line components that we have that we're working towards in the Astral architecture and why we're working on each of them. And then I'll talk through a couple of use cases that kind of point in the direction of what we think is possible. And then really, yeah, open it up for discussion and hear ideas. So again, a lot of this came out of work that I was doing during my master's research, that then when I got deeper into the Web3 space, I discovered that a lot of other people had been asking and working on similar things. One of them is actually here, Volker. We've never actually met, but your work on looking at IPFS and storing satellite imagery on IPFS was really inspirational to us. Holly Grimm here was working on some very interesting regenerative finance protocols before regenerative finance was really a thing. And so for the first few years of Astral, we basically prototyped a couple of location-based applications using decentralized computing technologies, and through that found these common requirements that have sort of formed what we now think of as the Astral protocol. And the idea being, if these are needed for a couple of different use cases that we were experimenting with, the chances that they will be useful for a lot of other use cases is pretty high. So I kind of think of this as 3 different islands or continents in the world of Astral. One of them is the idea of a verifiable spatial data registry. And I really kind of think of this as an on-chain geodatabase, right? So this is an on-chain base map. What you store in the geodatabase could be anything. Could be a set of points. Early work on a verifiable spatial data registry would be FOAM's, what was it called? The like points of interest map that you had, which was like a token curated registry of different places in the world, sort of a decentralized alternative to Google Maps. But it could also be line strings like roads or rivers. It could be polygons. That's one I'll talk about a little bit more. I've also thought a little bit about some crazy ideas like putting networks on chain and then doing on chain shortest path analysis, this kind of thing. With Collectivo, we came across this idea of tokenizing these geographic features, and that sort of gave rise to the idea of a geo NFT, geographic NFT, which is essentially each record in the geo database is represented as an NFT, and then it is composable with the whole NFT ecosystem. That's something that honestly, I haven't even really thought through what's possible there. But we're kind of building the most basic tools and trusting that the community will take this in places we would never expect. And that's actually what Collectivo did when they found some of our earlier research. A big part of this is a Solidity library that we've been, I'd say, designing and kind of thinking about for a long time, but we haven't actually really gotten into the heart of building out in a sort of production grade, which is called spatial.sol. This is basically a Solidity implementation of a library like turf.js, right? So you've got all of these geospatial functions accessible in the Ethereum virtual machine. So things like, what's the bearing between 2 points? What's the distance? What's the area of a particular polygon? Do these polygons intersect? It's one of those things, again, where we can't necessarily imagine all of the use cases for this stuff, but we figured by providing the most basic tools, we could actually open up a lot of innovation. The function there that I think is actually personally most interesting is the point and polygon function, because if you have an on-chain base map of polygons, and then you also have a point and polygon function, you have the opportunity to create what we call local smart contracts, where the behavior of the smart contract changes based on where the person is who's submitting a transaction. So you can imagine at the start of a smart contract function, a require statement that says, require that this person is in Denver, and then suddenly you have a smart contract that's only relevant to Denver. I think there's a real interesting design space here to think about kind of on-chain or blockchain-based spatial governance is the way we think of it, which a lot of our governance systems are dependent on where you are, right? They're based on which country you're in, which city, which state. So in order for that to work, the other thing we realized we needed was verifiable location claims. And again, this is really heavily inspired by the work that FOAM's doing with their trust zones and their sort of dynamic proof of location protocol, decentralized take on GPS or related to GPS. What our kind of emphasis came to be was to think about a standard verifiable claim or credential that something, some sort of likely digital device was somewhere, and then kind of allowing the community to decide what level of trust or what kind of different forms of attestations could be attached to that core claim that would reach a threshold of trust that they needed to accept that as a valid location claim. Because if you think of the range of use cases for this, it could be, I want to claim an NFT that I was actually at ETH Denver, up to, military applications, major strategic applications. And it wouldn't make sense to have the same security requirements for each. So the decision was, let's talk about having a core spec and then the ability to attach additional evidence that someone was somewhere to that verifiable claim. So this could come in the form of technical attestations, like I had a local node with a private key sign my verifiable claim that I could only connect to on the local network. There could be social attestations, like the 5 people who are together all check in together and sign each other's verifiable location claims. There could be economic mechanisms for ensuring this. There's a lot of different ways we can kind of pile on trust that these verifiable claims are credible. And so that's something that I think is, we've sort of touched on and done some early design work. Holly probably could speak a little more to exactly what our thinking is there in a technical sense. But I think this is designed to be the point that fits in with the polygon and the point in polygons function on spatial.sol. There's obviously some real questions around whether or not we want to be sharing where we are on a public blockchain, which leads to the natural kind of insight that zero knowledge location claims are really the holy grail here. Astral funded a project called ZK Maps, which was one of the finalists at ETH Denver last year. And their team has been pushing forward on really interesting work, developing different forms of verifiable claims with different zero knowledge proofs. I couldn't speak to it technically, but there's ways to keep the actual position private. There's ways to keep the actual kind of geography that the position is within private. There's a lot of opportunity space here. And then the sort of final island, I'd say, in the Astral archipelago is Web3 native spatial data storage and access. So this is for bigger spatial data that's not appropriate to store directly on chain, but we want to have stored on a decentralized storage system like IPFS. And I think this is really what Volker's early work really inspired, these questions of, how can we store the world's historical record in the form of these time series of satellite imagery, for example, on an organized system on the decentralized web. In my past, I was a developer advocate at Ordnance Survey, and Volker's comments about the inefficiencies in distributing these large geospatial data sets that have daily updates, that those are very, very real. And I think there's a lot of potential in using content addressing to manage these. My pipe dream is that you've got a geospatial database on the decentralized storage system sitting behind an application like QGIS or ArcGIS and or PostGIS, and the actual interface is the same, which means that you could plug directly into all of the existing geospatial data querying tooling. I know dClimate has been doing a lot of work on figuring out how to do efficient spatial temporal querying of decentralized data sets. It honestly is a bit beyond me, but fortunately I have some people in the room who could speak to some of the more technical aspects of this. Now, all of this kind of gives rise to Web3 native GIS systems, decentralized location-based apps, so peer-to-peer alternatives to Uber or Airbnb or Tinder, and then also where it kind of ties into my work at Toucan, digital environmental assets like carbon credits that are backed by DMRV data and having a fully decentralized computing stack for the entire data architecture and kind of financial architecture. I have a couple of use cases I'd love to talk through to just sort of put a little bit of flesh on the bones or inspire some thinking about what's possible with these different pieces, but maybe I'll pause here and see if anybody has any questions or comments, or I'm especially interested in people pointing out things that we're missing or ways we're being stupid.
And so before we launch into that too, I had not introduced before John Solly, who's with the Easier project. He's a geospatial developer there. So him and I will be taking some notes. So we'll try and record as much as we can, curate that up and share that afterwards as well. But if anybody wants to go ahead and kind of kick it off with a question or a comment, you can feel free to go ahead and ask that. You can drop it in the chat, whatever you're more comfortable with.
Holly. It looks like you're still on mute, Holly.
Sorry, I thought I would share a link to a Medium article that we wrote for Colectivo. I don't know if you have that. This is, this is the work that Danny, who's also on the call, Danny Serrano and I did on geospatial indexing on chain using geotrees and geohashes. So I'll just put that out there too. So that's kind of what we've been working on, the past year. And additionally did some work with dClimate and Revive Turner on spatial data indexes using off-chain methods in MongoDB in particular. So I just wanted to add that in. So see, did you want to say anything about Daniel? Did you want to say anything about the architecture, or do you have anything you want to add?
Well, I don't think I have anything particularly important to add. Yeah, I think those papers or those articles are interesting on how we manage this data structure. But at the end are those like implementation details on like complex data structure. But yeah, I think it's maybe worth to check it out, those articles.
Mm. Cool. Let's have Christian, and then I'll just to sort of finish the story, talk about a couple of the use cases, and then we can have probably broader discussion. Christian, yeah.
Cool. Very cool. I love this idea of like location dependent smart contract function. Not even sure exactly what could come of it, but it's kind of a cool concept. One thing I think about a lot is the value that it creates to information depending on how it's structured and how it's accessible. So it's like centralized information I could call like my cell phone. It's just like there with me. I mean, yeah, there's programs sending it all over, but like my location sitting there with me in one place. And then the next is like distributed information, like the IPFS layer that adds this peer-to-peer ability to move it around or share it in this new and different way. And then there's actually on-chain. And like, I almost think about the amount of information starts to get narrower up, and like only the most useful, valuable information on chain that is, because it's on chain, actually accretes value versus the next layer down. So I almost, with these kind of problems of thinking, I'm always trying structure it into what tier is it most valuable in, given the constraints of the tech and other features.
Yeah, absolutely. We can talk a bit about that too. That's something we've thought a fair bit about. Mo, hi.
Could you define what value means in this context? Is it like speculative investment and like increased valuation of tokens over time, or is it like utility for people using the system, or is there like some other type of value?
So I definitely wasn't thinking of it in terms of the first sort of specific case, like investment value is not how I'm thinking. Think of it as utility for the purpose of the application or system or intent behind the community, more so than anything like monetary specifically value.
Cool, thank you.
Cool. I think we can probably have a pretty deep discussion here. So let me just wrap up my little section by talking about some of the use cases, which hopefully will maybe clarify why we've landed on this architecture and inspire some thinking around what can be done. And then, so where we are at the moment, we're an open source kind of software development and resource or research group, and we've got pretty decent kind of handle on a lot of the different work that's happening in the Web3 geospatial world, and even more now having met all of you. And I think we're here to help Taylor and John really kind of coordinate the effort of building out these different open source tools so that we can end up with a really comprehensive geospatial data computing stack or set of technologies on the decentralized web, and open up what I see as a new category of decentralized applications, spatial and location-based applications, right? So some of the projects that we kind of prototyped to learn what it would take to build location-based applications on the decentralized web, and really kind of gave inspiration. A lot of these different components came out of us building these. The first is a project called HyperAware, which is a spatial governance protocol for connected devices. This is what we call it. And it's essentially the first use case or application of HyperAware was congestion zones. So if you're not familiar, congestion zone is a kind of area in a city where there's a fee to drive a car or vehicle into the zone. And at the moment, a lot of these use automated number plate recognition. Take a picture of your license plate when you drive in and pull out your license plate number and then charge you based on that. And we thought with the machine economy rising and connected devices kind of advancing so quickly, there's a lot more we could do if we have IoT devices embedded in vehicles and we're connecting to some sort of computing system, so backend or cloud. So in HyperAware, the sort of general architecture is congestion zones are stored on chain in a verifiable spatial data registry. These could be tokenized as GeoNFTs or not. And then vehicles are generating these verifiable location claims and submitting them to a smart contract through a invocation of a method. And then on chain, we're computing whether or not the point is inside of a particular polygon, and then detecting how long it's inside a congestion zone. And when it leaves, there's an automated payout from a smart contract wallet. Now, this might be a bit of a stretch. I don't know if submitting hundreds of thousands of millions of points to a blockchain, a smart contract every minute is really scalable. But what this points towards is this ability to adapt smart contract behavior based on where a vehicle is or where a person is. And so this was kind of the first idea, the first prototype we built pointing towards that. What are the benefits of this? Well, one is that with Ethereum or EVM or just blockchains in general, we essentially have a globally accessible kind of computing system, right? And so if we have a situation, I always think that blockchains are most useful when you think on the level of markets or communities of actors rather than individual market actors. And in the case of nation states or other kind of sovereign governments or regional governments, coordination amongst these groups is really quite difficult. But people and cars and trucks and planes transit through these jurisdictions all the time. So I think of this blockchain system as a sort of globally accessible system that no matter where a truck is in the world, it's submitting to the same data storage system, and each jurisdiction can have autonomy and control over the rules that apply within this jurisdiction, but there's still this sort of global governance system that takes into account where things are. So this could be easily adapted to use for location-based voting, taxation, local and complementary currencies, and this idea we've been working on called spatial demurrage, where the tax applied to someone's holdings in their account is contingent not on just time, but also on where they are. So the further away you get from a community, the more kind of tax or fee you pay. Could be airspace restrictions, governance of autonomous vehicles. So in this case, these red points are verifiable location claims submitted by vehicles, and the congestion zones or these jurisdictions are represented as polygons that are stored in a smart contract. and the computation happens on chain. I think this is definitely not reasonable for Ethereum mainnet, but with a lot of the scaling solutions, layer 2s, layer 3s, as well as the Filecoin virtual machine, I think we're moving towards a world where these kinds of on-chain GIS functions or computations is maybe realistic for appropriate use cases. So this kind of is the more, I'd say, vector-based decentralized application. You could imagine something where there's some sort of matching algorithm between drivers and riders. You could imagine that there's a lot of different ways we could take some of the inspiration from this, from hyperware. And then another use case that's from actually a partner of ours built with Holly for most of last year, trying to build tools for regenerative economies at Collectivo. And this involves essentially creating a, well, more or less designing local currencies that are tied to the health of local ecosystems. And this meant storing the bounds of those local ecosystems, these impact areas, as geo-NFTs on a verifiable spatial data registry, and then collecting MRV data, right, impact data for monitoring, reporting, and verification, and attaching that evidence to verifiable location claims and storing that on a decentralized storage system, and then submitting the ecological state metrics to smart contracts. And in Collectivo's case, they tie that to monetary policy or financial policies. So this could be kind of, yeah, how much of a currency is minted or claimed back from a community. It could be tied to interest rates. There's a lot we could do with sustainability linked finance. It could be tied to parametric insurance products like what Arbol and dClimate are doing. So these two, I picked these two just because they kind of, I'd say, stake out the boundaries of what's possible when we start to work with spatial and location data in the decentralized web. And hopefully, I mean, Astral's plan is to not pick what application layer product we want to build, but build the tools for different product developers to be able to very quickly build with location data, which all of you know is very tricky to do on the decentralized web. There's a lot of technical challenges. And if we can bring down those barriers, we think we can open up a lot of innovation. So I think I'll stop there. Yeah, and more. What else can we build? I'll stop there. I think we've got about 20 minutes left for discussion. And yeah, Taylor, maybe you want to kind of transition into the next part of the session.
Yeah, I mean, we wanted to have time for open discussion, give other folks a chance to chime in, ask questions, comments. So we can do that for a bit. And then I just wanted to watch the clock and maybe save at least 5 minutes towards the end. I'd like to get kind of folks' feedback and feeling like what would they like to see going forward with the working group, like what would bring them out for an hour, maybe every other month or something like that cadence. If it's speakers, or they'd like to see other things, kind of being planned. It could be tutorials or an in-person workshop as part of a larger event later on, something like that. But we can kind of collectively work towards that stuff. So I'll circle back to that at the end. But for now, does anybody have any kind of, we could start with a question or any other comments or anything like that? And we've certainly got some. So no, you got Wes.
Hey, John, this is Wes from Project Bakuya, and I apologize. I had to help cover for a teammate, so I was a couple minutes late. But if you didn't cover it, if you covered it already, just let me know. I won't take any more of your time. But if you did not cover it, do you have any opinion about the state of the art of provable location in terms of someone comes to say, oh, that could be fabricated? Like what are the best approaches or what are the future approaches that you'd like to see that underpin the trust behind these measurements?
Yeah, so I touched on it briefly. I can kind of, it's a really interesting, really challenging question. So I can in 10 seconds or 20 seconds summarize my attitude, but we also have Ryan King in the room who's like thought about this possibly more than anybody on the planet. So I'd also love to hear your thoughts, Ryan. But I mean, our attitude at Astral is we want to build unopinionated tools. right? So we want to build tools that are useful from people ranging from, I want to claim an NFT at a concert, to we want to prove that a nuclear weapon was handed off between two, militaries in a safe, secure way at a particular location. And the trust requirements for those are pretty widely ranging, right? So the verifiable location claims or verifiable credentials, location credentials that we've been working on take this sort of core claim, and then the plan is to enable the community to build extensions to the claim that allow you to attach additional evidence that you were at a particular place at a particular time. And that's open to whoever wants to do whatever. So in this case, it could be, hey, we got this position from the GPS network. That's going to carry a certain level of trust. But if you got it from a foam trust zone, then that might be a higher bar that other kind of applications have a need for. We can kind of follow up. I did talk a little bit about it, Wes, but we've talked about technical ways of adding on that trust. We've talked about social ways, there are economic ways. I'm kind of philosophically of the mind that it's impossible to prove that a particular number was created somewhere in the universe, but I think we can add on layers of confidence and then essentially leave it up to the application developers to say, all right, this is the threshold that we require. In order for you to call an Uber, you've got to have, I don't know, it's pretty simple. Whereas in order for you to pay your taxes and prove that you were somewhere, then there's another layer and another layer and another layer, right? So yeah, Ryan, I know you've got your head around some of the more technical ways with the foam trust zones. Do you want to maybe kind of comment on Wes's question?
Sure, thanks, John. And yeah, I think there's a lot of opportunities for kind of either lesser forms or attestations or some sort of trust anchor model where maybe there's even like a kiosk that is known you check in with, or social graphs. There's all different ways to try and attest or prove location on chain, which are all great. The way that we've gone about it is trying to think of the way that would be the most difficult to cheat or spoof. And with that comes kind of the most overhead in terms of equipment or cost. But our system is similar to GPS, although it's ground-based. So with your phone, if you're listening, opening your Google Maps, trying to find your location, sometimes if the blue dot's moving, that's because your phone needs to hear at least 4 GPS satellites to do what's called time difference of arrival, which is how your location can be calculated. So we're doing something similar where you need at least 4 of our radios to be deployed. They're low power, and that forms a zone of coverage. You can then add 5, 7 or more to expand the zone. And they're kind of doing this time synchronization protocol amongst each other and figuring out where each other are. And then the main difference with GPS is that a user then nearby this zone can actually talk to it over radio and sign a cryptographic message, have a cryptographic handshake, this kind of back and forth that doesn't exist in GPS. The location can then be determined, and then that can be used on chain. So this location claim we see as just like a base primitive that then can be added into any of these applications that have been discussed, where maybe instead of submit your GPS or submit this POP, also the app might ask submit this location proof you got from foam. That's kind of like the hardest or most robust one, but does require like custom hardware and things like that. We've built out the system and we're currently beta testing it. So if anyone has like specific locations where they might want to test this, happy to get in touch.
One interesting thing here is these location claims don't, like, I kind of think of that as the key to fit the lock, to say, all right, here I am, let's change what, incorporate that into the business logic. But I guess it's just relevant to mention, this doesn't have to be submitted to a smart contract or some sort of Web3 system, right? This could equally go into an Amazon server and being, so the libraries we build are not necessarily have to be this like one integrated monolithic architecture. I don't have a lot of experience designing standards and getting them adopted by industry. I have a feeling the people in the room have way more insight into that. So I'm kind of here just to offer up some of the thinking we've been doing at Astral, and then really just kind of see what sticks, right? Like there's obviously a lot here and it'll be a long time before all of it gets built. But if anyone's working on specific kind of specific things, you know, we're going to push things forward in different fits and starts as needed.
Thank you.
Any other questions?
Hello, this is Demetrio Wizard. And let me introduce myself really quickly. By trade, I'm a digital transformation consultant, so traditional for working with firms to improve their information systems. And just taking off of Wes's question, I posted a link in the chat here about the Lego, something I recently learned about that helps with fraud detection. Well, not fraud detection, but fraud defense, and being able to develop functions or ways to detect if there's information that's not true or could be simulated or lied about, and these functions help provide a way to verify or kind of like you say, but develop a string together to say, okay, you have to have all these factors lined up to be considered, to have your information considered at a certain level to be accepted. Now, whether somebody wants to accept it or not is going to be based on a standard that that community has for that. So if people don't trust a GPS signal, then that's going to be their choice, but there may be other forms that could be tied together. And I learned about this recently that seems to align to that concept of, we're going to provide the data, people will be able to verify in different ways and use what they desire for that. And other people will have to kind of align with what that verification process is. So just wanted to add that piece. Thank you.
Yeah, no, I think that's spot on. And thank you for servicing that. I think the verifiable location claims could be a perfect Lego. When I use my mobile banking apps, they will use where I am as part of their fraud detection. And if they detect a request that comes from somewhere they don't expect me to be, they might flag it up. So I think, that's definitely relevant. And I think if anybody is interested in looking at building out a Lego for Gitcoin that includes where you are, we'd love to support that. However that might look. Cool. Thanks, Demetrio.
Hey, maybe this was brought up in the beginning. Sorry, I jumped on. I saw John tweeted this was happening, and so I jumped on pretty late. But I just have the basic question of how can I tap in more to this community and just better keep track of or contribute to some of these efforts that John and most likely others are talking about.
I think there's probably a couple of ways. I know that so we're looking to kind of keep this group going. We're hoping is the plan to try and have like a bi-monthly meeting. So we've got if John Sully, if you can put the link to the website there, we'll keep like a running web page going for the different events, and then we'll try and do a write-up of the notes afterwards so folks can follow that way as well. But I think the work itself, probably looking to outlets like Astral. John, I don't know if you want to talk about any ways that you guys push updates on things that you're working on.
Yeah, we're kind of coming into a new chapter, and the plan that's taking shape is to really lean into professionalizing the open source development of this. And goal is to essentially create a board with a bunch of tickets of things that need to get built. Honestly, I would love it if this community was kind of, you all are the ones who have more insight than me. I'm the guy waving my hands up here saying things that hopefully connect with you, but you're the ones doing the work to build this stuff. So I kind of see if we take this sort of like continents idea, I'm at 30,000 feet saying, I think if we built this in a way that it all fit together, this could open up some interesting ideas. And then each of you are down actually doing the real work to build it. So I'd say, using this working group as a space, coming to me and sharing. I think Mo, for example, this data indexing, right? This is like super, super critical work. I think that will open up a huge range of use cases, including for groups like the ESA or the Landsat project or Ordnance Survey. And I think so. Yeah, I guess as far as next steps, like what I'd love to see is maybe a session in the future where we take some of these high level ideas and go in and color in a bit of detail of, all right, zero knowledge location proofs. We could bring the guys in who are working on ZK maps. They've got a lot of thoughts around what needs to be built. They've got a lot that's already been done. We can post links to GitHub. They can say, hey, this is the next step. This is the next step. And that's true for basically all of these different parts of this vision that we have. And then, yeah, from there, figuring out who the best people are to build that and what they need to do that work. And I think my goal here is to help you, Taylor, coordinate this, because we have an opportunity now where if we build this in a way that it all kind of composes, we can together build something that's so much bigger than what any one of us could build. And I think that's, to me, the beauty of Web3, and it's why I'm here. And yeah, so maybe it's not a brass tacks answer, Taylor, but it's, again, I'm the guy who waves his hands around. So,
well, I think it could be interesting to have something, continuously refined version of the Figma that you had introduced, but we could basically pick chunks of it, right? And say, okay, we're going to highlight this chunk at this meeting, and how we do that could change. And, if there is a particular speaker that can speak to that, we could invite them, have them there, have a discussion around it. But as we gather resources, whether it's a project, a recording of a speaker, or other links, we can kind of fill those in under that chunk of the Figma and just kind of have the Figma grow that way.
Yeah. And it would be great if people say, hey, I want to work on this. If they come and there's just all of the work that's been happening in that particular area are compiled into one place. The people who have the state of the art knowledge are accessible. That to me is going to be how we can have this technology stack develop as quickly as we can. So, I think maybe it's also partly each of you kind of submitting the different repositories and blog posts. I've already been copying basically everything that's already been posted in the chat, and we already have a nice little repository of resources forming. Yeah, that's kind of how I'd love to see it go, personally.
Sounds pretty good. We're taking some notes as well. Any other kind of questions, comments, what you'd like to see?
If I may,
Sure.
I'm into this thing called like local first software. So stuff that doesn't strongly rely on the cloud always being online and some corporations owning a bunch of tech infrastructure. So it'd be really cool if we could explore stuff in that direction of like, how can we get spatial web data without having to have some like multi-million-dollar budget of running these chains and like relying on these always online internet connections to make stuff work. So I've been thinking about that a lot. And I think there's a lot of overlap where we can use chains for the places where we really need them, but then we can use more like fully decentralized and peer-to-peer alternatives for the data layer itself to just kind of make applications more resilient and less dependent on centralized-ish infrastructure. So it'd be cool if we could talk about that more too.
That's really inspiring, Mo. That reminds me of one of the ideas I heard from Andrew and Carson on the power of having vector map tiles on IPFS in context of disasters, right? If a local rural area gets cut off from the internet, but can fetch high resolution maps from local peers, I'm never going to load the road network of a small town somewhere in the middle of wherever, but to that local community, they really need that. And having that high resolution data cached in the local area where it's going to be needed most, I think that's a really, really good example. And I think, yeah, generally that idea of local first software, I think that's brilliant, and I'd love to learn more. And I think this community is the right community to be thinking about that because of the principles of the decentralized web. So yeah, great. Thanks for the contribution.
Any others? One of my own kind of, I know we're getting towards the end of the hour, so we can definitely wrap. One of the things I'm kind of interested in as well is we've talked a lot about different technological elements, but also a little bit of the human element in terms of adoption. So coming from kind of like the academic kind of perspective, it's really hard to get people to do new things or change their workflow. So even just taking a paper that's been published that's, you know, adopted science and saying, well, like, how do I make that open and replicable and usable by others? So my answer would be by using some of these technologies, but then you obviously have to get them to adopt that. So I know Volker was saying he's got 5 more years to get like the ESA to use kind of distributed technology internally. And so I think there's a huge human element to that as well, in addition to the technological element. And so I think that's an interesting one, you know, to keep in the back of mind that could pop up from time to time and see what we might be able to do about it. Carson?
Yeah, so related to that, Taylor, I have a student who has graduated and is looking for academic positions, by the way, if anyone knows of any. But he did some really great work on essentially like like geospatial data sovereignty of like the communities that are generating those data. So in particular, in the Canadian North, he was working with Aboriginal groups who pretty much just don't trust the government to like handle their community data in a way that like, you know, preserves the sovereignty of that data. And so these types of like systems where there's a lot of peer ownership and like ability to transfer peer to peer, or ability to have sort of like permissionless but curated geospatial data sources is actually really powerful in terms of like, you know, giving voices to people who don't normally have voices, and these types of like data protection things outside of just like technical access and things like that. There's also just actual like social access and community access, which is important to keep in mind. And it also ties into like geospatial data is often disputed, right? Like boundaries are constantly in dispute over geospatial areas. So like, how do you deal with that when something's just stamped onto a blockchain somewhere, and, you know, later on, and there's a dispute over that, the actual boundary. So there's also that aspect of things. You know, imagery is one thing, because it's like a satellite took it from space. It's kind of like, you can't debate that the picture was taken, but like boundaries, official boundaries and unofficial boundaries and neighborhoods and all of this stuff is always kind of contentious as well. That's the academic piece of it.
Yeah, it's really kind of a big part of thinking behind these verifiable spatial data registries. You know, border disputes are the basis of maybe most wars, you know, and so thinking about developing really robust governance systems to manage boundaries and the resources, you know, that lie within them, and thinking about how to encode those on a machine readable system rather than in a series of treaties, which I think is especially relevant as we move into the machine economy and we have autonomous vehicles, we have autonomous ships, and, you know, moving into autonomous weapons feels like having, like, one thing I really value about a lot of the thinking behind the Web3 movement is encoding the rules of the system in at a technical level rather than on a policy level. And I think, you know, when we have weapons that could do immeasurable damage to a city in an instant, having some technical checks on top of the international law is probably something to work towards. But I guess, and maybe this is a bit of a closing thought, this is really fraught, right? Like, we're moving into a really, really tricky technological world that could go a really dark direction very quickly. And so I think we need to put a lot of care and thought into how we design these systems that we hope will eventually play a big part in coordinating our society and underpinning the way humans work together. And that's a big reason why I'm so excited that Filecoin and Protocol Labs are behind this, because I know there's a real deep ethos there of being very thoughtful about the way that the systems we design will actually manifest at scale and how they'll impact the way we treat each other. Yeah, it's a deep subject. There's a lot to think.
Sure. But I think we can definitely keep that kind of stuff in mind as well, and try and pull folks into the meetings that may not be as interested in developing the technology, but may be interested in learning about it and what it can offer. I think that's also an interesting kind of component of it all. So I don't know if there's any other kind of last words or last comments. Otherwise, we can kind of move to adjourn. I put the link one more time for the HackMD in the chat. So if you think of anything after the fact and you want to throw it in there, we'll keep an eye on it for a bit. This way we can use that for some asynchronous communication, but we'll try and go ahead and do like a redux on the notes. John, you said you had some notes as well, so maybe we can just communicate via email a little bit, and then we'll try and like push that out to folks and just give them an update and see where we can go next and when we can schedule a follow-up meeting.
Great.
Cool. Thanks so much, John, for agreeing to be a guest. We really appreciate it.
Well, thanks for having me. And yeah, this is just the beginning. There's a lot of really exciting work to be done. So so inspired by the people in the room.
Thanks, everyone.
Thanks for coming out all. Take care.
See you.
Goodbye.